Hi, my name is Maia and I'm a third-year PhD student from the Weed Science program. On this video, I am going to present a project where I'm investigating the effect of simulated rainfall on atrazine wash-off from cereal residue. Cover crops are planted right after the cash crop harvest and are terminated on the spring of the following year, before the next cash crop planting. They provide protection against soil erosion, increase soil organic matter, scavenge nitrogen, and have a few other benefits to the soil. The most common way of terminating cover crops is through the application of herbicides. A practice that is becoming popular is the inclusion of a residual herbicide at cover crop termination, which is likely to reduce the selection pressure for herbicide resistance and extend the period of weed control. The negative aspect of this practice is that some of the residual herbicide that should be in the soil will end up being intercepted by the cover crop, and once that interception occurs, that herbicide can only move to the soil with rainfall or irrigation. The objectives of this research are to determine the amount of atrazine that reaches the soil at the time of application, determine the amount that is washed out from cereal residue after rainfall simulation, and we hypothesize that at the time of application, less atrazine will reach the soil underneath roller crimped cereal compared to standing cereal, and atrazine applied to roller crimped cereal will become more readily available in the soil relative to when applied to standing cereal. Our field trial was conducted in a split plot design with rainfall treatments being the main plot and the cover crop orientations the subplot. Atrazine was applied to all plots precisely 30 minutes before the rainfall simulation that lasted for 20 minutes for each plot. Around 90 minutes after the rainfall simulation, we collected plant and soil samples. The rainfall simulator was developed here at Purdue by the Weed Science team, and we used two different nozzles to simulate two rainfall volumes, and as you can see on the video, the nozzles were constantly rotating 45 degrees back and forth to simulate the impact of the water droplet on the plant surface. We observed a 67% reduction on the concentration of atrazine after 25 millimeters of rainfall on the cereal plants that were left standing on the field. On the same rainfall treatment, the concentration of atrazine was 102% greater in cereal that was roller crimped compared to the standing cereal. Also, after 25 millimeters of rainfall, we measured more atrazine in the soil under roller crimped cereal compared to standing cereal and fallow. This data suggests that the roller crimped cereal is reducing the rate at which the herbicide is being released onto the soil surface. We conclude with this research that the roller crimped cereal is acting as a slow release mechanism of atrazine onto the soil, which can be positive if we think about the groundwater contamination, but can also be negative if we think from a weed control perspective. With that, I would like to thank you for your time and feel free to contact me if you have any questions.